Hello friends, my name is Desmond. I'm a final year computer science student at University of Malaya, and in this video we are going to try to attempt to solve the imitation questions for lab 4, which is flow of control or repetition. So there are in a total of 8 questions. So let's get to it. Alright, so the first question, it asks us to write a program that displays all the factors of a number. So to write this, let's first declare n as 6. So n will be our number, and in order to find the factors, we are going to do a for loop that starts from 1 until n, and then we increment by I. We increment by 1. Okay, so in this for loop, we are going to check if if n divided by I, the remainder, is it 0 or not. So if 6 can divide this number completely without remainders, that means this I is a factor. So we are going to output that to the screen. So let's try to run this. Yeah, we should get 1, 2, 3, and 6, which are the factors. So let's try to change this number to 12. And we are getting 1, 2, 3, 4, 6, and 12. That's it for question 1. We're going to move on to question 2, which asks us to print the following series. If n is 3, if the given n is 3, then we should print out 1, 3, and 6. And if the n is 5, then we should print out 1, 3, 6, 10, and 5. So 1, the first number is 1, the second number is 1 plus 2, and the third number is 1 plus 2 plus 3. So we can see the same pattern here. The first number is 1, the second number is 1 plus 2, the third number is 1 plus 2 plus 3, the fourth number is 1 plus 2 plus 3 plus 4, and the fifth number is 1 plus 2 plus 3 plus 4 and plus 5. So we are going to need 2 for loops, but we have to first define what is our n. Let's say 3. And let's do a for loop here. Int I equals to 1 because we're starting from 1. And then it should be less than or equals to n, and increments I by 1 every time. And we should also have a nested for loop here that starts from 1, that is smaller or equals to I, and j++. So this outside for loop would run for every output. So for example, it will run 3 times for number 3, which outputs the first number, the second number, and the third number. And the for loop inside would do the addition. So for the first number, it would just print out 1. For the second number, it would do 1 plus 2. For the third number, it would do 1 plus 2 plus 3. So in order to do addition, we're going to put a temp sum here, equals to 0. So this temp sum is the accumulator of the j values. And we are going to output temp sum out to the screen. So well, let's try to run this first. 1, 3, and 6, and when n is 5, should be 1 plus 3, 1, 3, 6, 10, and 15. Cool. Okay, so the outer for loop is run once for every number, and the inner for loop is this few lines of code is actually doing the addition. So the first time it runs will be 0 plus 1, and we'll print out 1. And the second time it runs, it will be 1, 0 plus 1, save it to temp sum. Now temp sum is 1, and then it runs the second times with j equals to 2, so 1 plus 2 is 3. Then it will save it to temp sum again, and we output temp sum to the screen. So that's it for question 2, pretty straightforward. And we are going to attempt question 3. Like usual, the main method. And for question 3, we are given an array of numbers. We are going to calculate the minimum, the average, and the standard deviation of the scores. So the formula for the standard deviation is given here. We just need to transform this formula into our code. So let's first type in our array of numbers. Let's call them scores. 40, 50, 78, 30, 90, 98, and 96. Okay, because we are calculating the minimum, we are going to set a min value to be integer dot max value. So integer dot max value is the largest possible number in the integer range. And the reason we're doing this is because whenever we are going to look for the minimum number, we are going to look through every number. So at first, I'm going to compare this to 40 and take the smaller value. So in this case, I will take 40 and set it to min. So now my min is 40, and then I will move on to the second number, compare 40 with 50, and take the mean, which is still 40, and move on to the third number, 78, and compare this with 40. So this mean variable is keeping track of the current lowest number, the current smallest number. So it's actually a good practice to set it to an infinitely large value so that it can work for any numbers in this array. Okay, then because we are going to calculate the average, we are going to have a sum of x, which has 0, and because in the standard deviation we have a sum of x squared. Okay, we're going to need that as well, and we're going to write a for loop just to loop through the array. Plus plus. Oops, sorry. And like I said just now, we're going to use the min method to set to compare every element in the array to the current minimum score and take whatever values that's the lowest. Then just this sum of x is just going to add the number that we have in this ith position in scores. And the sum of squared is pretty similar, except that we times the scores by itself before we add it. So a squared is the x squared is x times x. So this is what this code is doing here. When we're done, we should have the min score ready. Let's print that out, and let's try to run our code first to see that if it's working. 30. Yeah, so the min score in this array is 30, which is correct. And to get the average, we are going to divide our we're going to take these values and divide by the number of values we have in here. So we're going to take n, which stands for the number of values or the length of the array, and we're just going to print out the average to be double sum of x divided by n. The reason we are adding this here is because this was an integer and we want to change it to double before we do average, because if we don't, our answer won't have any decimal point. It will just do what we call the integer division. So we want to make sure that we change it to a double type first before we run the operation, so that this division would actually give out the more accurate decimal points answer. And we would also have a standard deviation, so we just try to translate this into here. So at first we have a very big square root, math of square root. So inside here we have a fraction. So the first part of the fraction is actually the sum of squares, sum of x squared, and it's going to minus sum of x times sum of x. And this is going to be divided by n, which is defined here, and the other part is just n minus 1. Okay, remember the semicolon at the end, and should output the standard deviation to the screen. Let's try to run this. So, okay, cool. We have the mean 30, the average is this, and the standard deviation is 28.32. So that's it for question 3. Let's move on to question 4. Alright, so in question 4, we are going to print the calendar for May and September. So the main thing that we need to do is to match in a way so that the 1st of May is a Friday, and we have to print that the 2nd of May is a Saturday, 3rd of May is a Sunday, and so on. So we are going to write a program to calculate the weekdays for every day in these 2 months. To do that, let's just define days in month. So this would be for January, February, March, and so on. So January has 31 days, and since it's given that year 2020 is a leap year, February should have 29 days instead of 28, and March should have 31, April 40, and then 31 for May, June 30, 31 for July and August, September should be 30, October 31, November 30, and December 31. And then we're going to have maybe this, a string of weekdays, and they should be Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, and Sunday. And then since it's also given that the 1st of January is Wednesday, maybe we should put that too. Initial, maybe pointer for Jan 1st is 2. So we say that 0 is Monday, 1 is Tuesday, so 2 is Wednesday. Okay, so in order to print a calendar, let's try to print for May 1st. In order to print a calendar, we need 3 steps. The first step is to calculate the days before May. So we are going to sum these 4 numbers up, and then we're going to use this 4 number with this number 2 here in order to know that that the 1st of May is a Friday. Okay, so the second step would be, let's say, to calculate the first weekday of May. And the third step would just print the calendar. Okay. So to calculate the days before May, we're just going to sum this up. So let's do a for loop, which starts from here and goes on until this. Okay, so days before May equals days in month I. So let's try to print. There are 70 days before May, and the percentage is days before May. Okay. So this piece of code, the first step here we are doing is actually calculating the number of days before May. So if May is this month, then this is January, February, March, and April. We are summing up these 4 months of days, the days inside these 4 months. So the day inside these 4 months is actually 121 days. And we are going to need this in the second step. So if you're a bit lost, right now, just stick with me, and you will see where it's used. So in the second step, we are going to calculate the pointer. Let's call this the weekday pointer. Weekday pointer for May 1st. So this we're trying to find this weekday pointer for May 1st. So it should be we have the calendar here. It should be pointing to Friday, which is number 4. So in the end, it should be 4. Okay, the correct answer should be 4. And we're trying to write a program using this information, days before May, and this information to calculate for this. So it's pretty straightforward. We just have to add this to the weekday pointer for January 1st, and then get the remainder value by dividing it with 7. So it's just modulus 7, and let's try to print that out. First day of May is a weekday pointer from May 1st, and let's try to run. Cool, so it's correct, and it returns the correct answer. The first day of May is a Friday, which is correct. So let me tell you what just happened. So by calculating the number of days before May and adding to this offset of the weekday, which is 2, then we percent it by 7, we will get back a weekday pointer for May 1st. And this is having a value of 4. So by plugging in this 4 into this array, we would get back Friday. So in the end, we are going to print out the first day of May is a Friday. So now that we have the weekday pointer for May 1st, we can finally print the calendar. Going to set a pointer here, and we're going to loop through the number of days in May, which this value is actually 31. So there are 31 days. This should be 31. There are 31 days in May. We're going to look through every one of them and associate every day in May to a weekday in May. So we're going to print 1 Friday, 2 Saturday, 3 Sunday, and so on. So this would run for, actually this is for every day in May. We are going to output weekdays, weekday pointer. We're going to increment the weekday pointer every time we run. And if the weekday pointer is 7, we're going to set that to 0. So this means that because we only have 7 elements here, so if we first start from Friday, like in May, the first day we're going to print 1 Friday, then 2 Saturday, and 3 Sunday. By this time, the weekday pointer is already at 7. So we are going to start over, set it to 0 so that it print out Monday next. So this should work, and let's try to run. Yeah, so this is working great. We have the first day of May is a Friday, and so on, and then the last day is 31. So now we're going to do the same for September. Actually, we just need to copy this and say that this is for September. We just change all this to September. Well, we could actually write a method to you could actually put all this code in a method so that you don't have to copy and paste. But in case you don't know what is a method yet, we're just going to stick with this method for now. Days before September. First day of September is okay. Cannot declare twice. Day in month, I'm going to set it to 8 to represent September. Okay, it should work fine now. Correct answer should be 1 for Tuesday. Let's try to print. The last day of September is 30, Saturday, and first day home. Okay, this is wrong. The first day should be a Tuesday. Okay, so this should be 8. Okay, so it starts with Tuesday and ends with Wednesday. Cool. So that's it for question 4. We're going to move on to question 5. So in question 5, we're going to write a 2-player dice game. Each player takes turn to roll a dice, and the first player to reach more than 100 points win the game. So the winning condition is more than 100 points. We just have to do a while loop here. First, we define 2 variables, score for P1 and P2, which is player 1 and player 2. And then we are going to create a random object. Remember to import. While true. So let's try to do for P1 rows. And then we are going to do the same for P2 rows. So for player 1, the row of P1 is equal to ren next in 6 plus 1. So this method would return a random number from 0 to 5. So it will return either 0, 1, 2, 3, 4, or 5. And then we just need to plus 1 at the end so that the interval becomes 1, 2, 3, 4, 5, and 6. So this whole thing would actually return a random number between 1 and 6. And we are going to add that to score P1. And let's print out, let's say P1 row P1, current score P1. Okay, then after printing that out, we're going to check if score P1 is larger than 100. If it's larger than 100, that means the player has won. And we should break out of this while loop. Then let's do the same for P2. Copy and paste. Change this to P2, score P2, roll P2, P2 roll P2. Current score P2. P2 is larger than 100, and P2 wins. So this code should work well. Let's try to run. Okay, so at first player 1 rolls a 4, the current score is 4. Player 2 rolls a 5, current score is 5. Then player 1 rolls again, a 4, so 4 plus 4 is 8. Player 2 rolls a 3, 5 plus 3 is 8. Then continue on until one of them, well, in this case P2 rolled a 4, so 98 plus 4 is 102, and P2 wins. Okay, so that's it for question 5. Let's move on to question 6. So question 6 is a very short question. It just asks you to generate question 6. Okay, so it just asks us to generate a random number. So we are going to need that random object. And we're going to generate a random number. Let's say within the range from 0 to 10,000. And based on this number, we're going to calculate the number of digits in this integer. There are two methods. The first method is just using toString, convert this to a string and output its length. So this doesn't require any looping, and it's fairly simple. Number of digits. Let's try method 1. Number of digits in num is integer .toString to convert this integer into string and output its length. Then method 2 using a while loop. Okay, so another method is we just keep dividing this number by 10, and eventually we couldn't divide anymore, and we output the number of times that we have divided. So let's set this number of digit to 1, because any number is, we assume that positive integers should have at least 1 digit. Then set this number that we have generated above to a temp num, because we are going to change this temporary number. So we are going to run this for loop as long as temp num is larger than 10. And we are just going to divide temp num by itself. Sorry, we're going to divide temp num by 10 every time, and every time we divide we're going to add 1 to the number of digits. So in the end we're going to print out number of digits in num is number of digits. Oops, number of digit. Okay, so let's try to run this file. Okay, so a randomly generated number in this case is 2408. Sorry, let me print out method 2. Okay, and run again. Oh, so the random number generated this time is 1785, and it has 4 digits. And using the method 2, which keeps dividing it by 10 until it is smaller than 10. Wait, if this is 10, okay, I think it should be like this. Yeah, if this is 10, it should have 2 digits. Right, yeah, so this should be larger or equals to 10. Just to care, so because if we have 10 here, if we put larger than 10, this code won't run at all, and we would output 1 for number of digits. So this should be larger or equals to 10. Okay. Try to run it a few times. Yep, so it's working fine. We are moving on to the next question. Question 7. So this is quite a long question, but we just have to implement this formula inside our code, and we should able to print this kind of table out. So this is a loan mortgage. So instead of asking for principal amount, because we are going to run this a few times to check, let's just set the principal amount to let's use double. Let's just set this principal amount to 10,000, the interest to 4%, and the number of months to 12. Okay, so let's print out loan mortgage for RM. 0.2F. So this would round this up to 2 decimal places. Then we should use printf instead. 4%, 0.2F. interest of %.2f for %d months P, I, and M. Okay, so let's try to run first. Yeah, okay, it's working fine. Now we're going to implement these formulas. So M is for monthly payment, and we're going to print that out next. So the monthly payment double M is equals to P times I divided by 12 and 100. And then this whole thing divided by 1 minus, in brackets, 1 plus I divided by 12 and 100. Okay, so this is math. This whole thing to the power of negative n. Alright, so that is for monthly payment. And let's try to print that out. Let's because this is monetary value, let's use %f and round them off to 2 decimal place just for consistency. Okay, should be 851.50. Cool. And we should create a new line over here so that it prints out in 2 lines. Okay, nice. Should also have a new line over here as well. Now we're going to print out this table. So in this table, we're going to look from small n equals 1 to n smaller equals to big N. And every time we would increment n. So the small n here represents the nth month. So at first it will be 1 and 2, 3, and so on until the big N, which is 12. Okay. So we're going to implement Cn, Ln, and Rn. So the Cn should be this one, and the Ln should be this one, and the Rn should be this one. So they should all be in double. The Cn equals to m times 1 plus I divided by 12 and 100, and this whole thing to the power of negative 1 plus big N minus small n. Okay, and then for Ln, it should be m minus Cn. And for Rn, it should be Ln divided by I over 12 and 100 minus Cn. Okay. Now we just have to print them out. We would use printf in this case, and well, %d first, and the tab, then %.2f and a type. Then we need to do this for 3 times 1, 2, 3. So there are 4 values that we need to plug in. This is the small n, Cn, Ln, and then Rn. So let's try to run this first. Alright, remember to change the n to \n for new line. Okay, so these numbers looks great. They are similar. So we also need to print out these titles here. So we need to print them out before the for loop runs. So this should be M and a tab, principal and a tab, interest and a tab, and balance. Okay, so that's it for question number 7. Now it's the last question. Check if an integer is a prime number or not. So to do that, it's pretty simple. Okay, so a prime number is a number that can only be divided by 1 and itself. Right, so let's try to ask an input from the user. So we are going to need a scanner, system.in, and then set the in and to scanner.next int. Okay, and then we are going to have a boolean variable called is prime. Let's set that to true first, and if n, the number given by the user, is smaller than or equals to 1, then it should be false. And for we are going to loop through this number and to check if it can divide. It can only be divided by itself. So int I equals 2, smaller equals to NO2. This is because we don't have to run for the entire range of the numbers. So if we are trying to check if the number 4 is a prime number or not, we just have to divide it by 1 and 2. So sorry, we just have to divide it by 2. So if it can be divided by 2, that means it's not a prime number. Similarly, if we are trying to check if the number 10 is a prime number or not, we just have to try to divide it. So for number 4, we just have to try number 2. And for number 10, we just have to try from 2 to 5, which is the half of this number. Okay? Then for number 100, for instance, we just have to try from 2 to 50. Okay? Because if we try to divide it by 51, or any number that is larger than the half of that number, we won't get, we know that there's going to be remainder, right? Because if we try to divide 100 by 51, it will be a remainder of 100 itself, right? So we don't have to run it all the way through n, we just have to do it until n divided by 2, the half of n. Okay, so if there's a number I that divides n and gives no remainder, so it's not a prime number and we should break out of this loop. So it should be only be divided by 1 and the number itself. So if it can be divided by some other numbers between this range, between 2 and n half, then it's not a prime number. and then we just have to output the result is prime. So let's try to run this question 8. Let's say 10, false. 3, true. 5, true. Correct. 7, true. How about 90, 91? False. 97, true. Okay, cool. So now we have completed all the questions in this lab. Flow of control repetition. So thank you so much for watching, and if you think this video is helpful, remember to share it with your friends. If you like this video, remember to give it a thumbs up and subscribe to this channel. Next time we are going to try to attempt the flow of control lab questions. So stay tuned for that. If you have any further questions, remember to leave them down at the comment section below. I will try my best to answer them. Until then, see you guys next time.